Hey guys, I hope you all are doing good. In this lecture, we will be covering some set properties, right? So I've written all the properties on the board. They might seem very complicated in the beginning, but I'll go slow and explain each one with Venn diagrams, right? So I hope that before watching this video, you have a very good understanding about how Venn diagrams work. So if you don't, then I would suggest you watch the previous video and then come back to this one. So Uh, just a quick note, these properties are super important. So when it comes to sets in your exams or in just in general, when you study about databases, it might be possible that you have to solve proof related questions. And it's very important that you know these properties when you solve questions like that, right? So in general, just a quick note, these are very important to understand. And let's start with the first one. Idempotent laws. It basically says A union A equals A and A intersection A equals A. All these properties are basically just common sense. It's just that they have been given a name. That's basically it. So let's try to understand A union A equals A. Think about it, right? I have the set A. I'm taking the union with A. What is union? Union basically combines all the elements of both the sets together, right? So, for example, if I have A equals 1, 2, 3, and I have, so if I do a union, which is I do 1, 2, 3, union 1, 2, 3. This is simply going to result in the set 1, 2, 3, right? Does that make sense? And that is exactly what this is saying. Now, if I take the intersection in this case, intersection basically means all the elements which are common in both the sets, right? What are the elements which are common? All the elements are common in both the sets, right? So it's going to result in the exact same set once again. I hope that makes sense, right? So it's just a very general property, which is if I take the union of the same set, then it's going to result in the same set. And if I take the intersection, again, it's going to result in the same set, right? Now let's try to understand the identity laws. So I hope you have a good understanding about the idempotent laws, right? Okay. Identity laws. Let's try to understand what does the name suggest. Identity kind of means that A in this case is trying to maintain its property, or it's trying to maintain its identity in this case. So if we take a look at it, A union the empty set. This represents the empty set, right? So let's try to solve it over here. A, let's say A is 1, 2, 3, union the empty set. Basically means combine all the elements together, right? Between 1, 2, 3 and the empty set. It would simply result in 1, 2, 3 over here. So if you think about it, this set maintained its identity when it was unioned with the empty set over here. I hope that makes sense, right? Okay. Now, if you take A intersection, the universal set, it results in A once again. So let's try to solve this once again. Let's say I have, let's say A is equal to 1, 2, and universal set is equal to 1, 2, 3. Think about it. A intersection with universal set would basically mean 1, 2 intersection with 1, 2, and 3, right? And what does this mean? Intersection means all the common elements between both of them, which is going to be just 1, 2 over here. So in this case, once again, when I do the intersection of the set A with the universal set, it kind of maintains its identity in this case, right? So that is why it's kind of named identities law. Okay. So I hope you guys have a good understanding about identity laws by now. Moving on, let's try to understand the domination laws. It says, now think about domination over here. In the domination laws, it's basically the opposite. The universal set and the empty set are basically dominating the set A over here, right? In identity laws, The set A was protecting its identity, and in domination laws, it's being dominated by the universal and the empty set, right? So it's kind of just a way to remember the difference between both of these laws. So if you do A union the universal set, it results in the universal set. And if I do the intersection of A with the empty set, it results in the empty set. So I'll again try to explain it with the example, right? So A, let's say, is 1, comma 2, and universal set equals 1, 2, 3, right? So if I take the A union universal set, meaning 1, 2, union universal set. Think about it. Union, what it does is it combines all the elements together, but the universal set already has these two elements. So it's simply going to result in the universal set once again. Right? I hope that makes sense. So kind of what's happening is the universal set is dominating the set A over here, and that's what it's resulting in. Now, so it doesn't really matter what A is, right? It doesn't really matter. The answer is always going to be universal set in this case. If I change A, add another element, which is still in the universe though, it's still going to result in the universal set. But now if I take the A intersection the empty set, what is the intersection? So if I take A, which is 1, comma 2, intersection the empty set. Think about it. Intersection basically means the common elements which are in both of them. Empty set does not have any elements, so what's common in both of them is absolutely nothing, right? So it's going to be the empty set once again, or I can say this empty set. So just try to understand that these are both the representations for empty set, right? Okay. So by now, I hope you have a good understanding about idempotent laws. Identity laws, to try to figure out, means the element A or set A is trying to maintain its identity. Domination means it's going to be dominated by the universal set or the empty set. Now let's try to understand what are the complement laws. It basically says A union A complement equal to the universal set, and A intersection A complement is equal to the empty set. I'm going to explain it with the Venn diagram over here. So let's say I have this Venn diagram, right? This is A and this is B. I'm sorry, wait just a second. So let's say I have, it's just A in this case. So let's say this is A and this is the universal set. A is simply going to be this region over here, right? And A complement is going to be this entire region surrounding A. So for example, if this is A, I'll represent it with these lines, and this is A complement. Union basically means combine both these areas, and it's simply going to result in the entire universal set. I hope that makes sense, right? I can also explain it with just set examples. So for example, A is 1 and 2, and universal set is 1, 2, 3. A 1, comma 2, right? Union with A complement, which is just going to be the element 3, would result in the universal set once again. I hope that makes sense, right? Okay. Now let's try to understand what is A intersection A complement. I'll try to explain it with this set examples again. So I have A over here, which is 1, comma 2. Intersection, it says A complement, which is just going to be 3 over here. Now think about it, right? What is common between both of these sets? Nothing, right? In intersection, we are supposed to find, or the combination is basically the elements which are common in both the sets. Since there's nothing common over here in both of them, this is going to result in the empty set over here. So I hope that makes sense, right? So just try to understand and remember these properties I would suggest. A union A complement means A combined with its complement, which is everything except A, we simply get the universal set. And if I take A and if I intersect it with or find common elements between A and what is outside, I simply get absolutely nothing, which is the empty set, right? So I hope you have a good understanding about the complement laws now. Moving on, let's try to understand the double complement law. I'll try to explain it once again with this example. So given I have A equals 1 and 2 and universal set equal 1, 2, 3. Now if I take just the A complement, so A complement is just going to be 3 in this case. I hope that makes sense, right? And if I take the complement of 3 over here, complement means all the elements which are outside of the set but in the universal set. So what are the elements that I have? It would simply be 1 comma 2 because that's what we have in the universal set over here, right? So this is exactly the same as A. Does that make sense? Basically, it means that A double complement is equal to A. If I take the complement 2 times, it's going to result in the same set once again. So I think this is a pretty easy law to understand. Nice. So I think we have covered 5 laws over here. Now let's move on to commutative laws, associative laws, and distributive laws. Now these are again pretty easy to understand because we have already covered it in math. I think we all have covered the properties such as addition is commutative, right? Commutative meaning that 1 plus 2 is equal to 2 plus 1, right? It doesn't really matter the order in which I write these elements. It's going to result in the same result, right? And what is associative laws? It is basically that I can solve for any part first and it would still be the same. So I can solve 1 plus 2 first and then add a 3, and I can do 2 plus 3 first and then add a 1. Basically, we know that addition is both commutative and associative, right? And that is exactly in this case as well. What these properties tell is that both the union and the intersection are actually commutative and associative, right? So I can take A union B and that would still be the same as B union A, and I can take A intersection B and it would still be the same as B intersection A, right? Same thing over here. I can do A union, I can solve B union C first and then union with A, or I can do A union B first and then do a union with C over here. And same is what this tells. So the basic point of these two laws is that both union and intersection are commutative and associative. They follow both of these properties, which we have studied in math, right? Now, distributive laws is again something that we have covered in math again. So I think we all know that let's say if I do 2 multiplied by 3 plus 5. One way to do is just directly 2 multiplied by 8, which is going to be 16. But another way is I can do 2 multiplied by 3 plus 2 multiplied by 5. Does that make sense? So I get 6 plus 10, which is 16 again. Same thing is happening over here. The difference is that when it comes to this over here, the opposite is not true, which is I cannot interchange these signs when it comes to just normal math, right? But when it comes to sets over here, I can interchange them, which is I can take a union outside and I can take the intersection outside as well. So A union B intersection C would result in A union B intersection A union C, and A intersection bracket B union C is basically A intersection B union A intersection C. This basic point of this law is that union is distributive over intersection and intersection is distributive over union, right? So that's what this law suggests. So these three are basically simply the laws that we already know from our high school, right? And basically we have added that to the sets as well. So I think we have covered commutative laws, associative laws, and distributive laws. Now let's move on to understand what is the De Morgan's law. According to the De Morgan's law, A union B bracket complement results in A complement intersection B complement, and A intersection B complement results in A complement union B complement. Now, what I would like you guys to do is try to remember this property, right? Both this property. We'll try to solve this through a question towards the end of the video, and I think that will make this law very clear to understand. Okay, for now, let's try to understand that if I take the complement of entire thing, the entire point, or I can say the summarization of this law is the fact that if I take the complement of a big operation, it's going to do the opposite inside of every single thing. So kind of like if you think about this over here, right? Let's say I have 2 plus 3 minus 5. I have this equation over here. If I multiply it by a minus 1, then it's going to do the opposite of symbols inside this over here. So it's going to do minus 2, minus 3, plus 5. And that is kind of like how the complement works in this case, right? That's just an idea of how it works, but I'll explain it through a question towards the end. Okay. Now, let's try to understand the absorption laws. Absorption basically means A is absorbing the set, right? The other set in this case. Let's try to understand it with a Venn diagram. Let's say I have this over here and these two sets over here, which is A, B, universal set, A, B, universal set. Think about it. Let's first try to figure out what is A intersection B in this case. So A intersection B is just going to be this region, right? And if I take A union with its intersection, it's going to be just this entire region, right, which is going to be this entire circle. Hence, it is exactly the same as A. So these are basically just properties that we already can figure out ourselves, but they have been given names and they have been kind of formalized in this case. So A union, the entire set, union with what is common between both the sets, basically results in this A set once again. And now let's try to solve for the other part. A union B would basically mean this entire region, right? Intersection with A basically means what's common in this entire region and A. So it's simply going to be just A over here, right? Which is this entire region. So I hope that makes sense how absorption laws work. So now we have covered 10 laws, and now let's move on to understand what is the set difference. So given A minus B is equal to A intersection B complement. I'll try to explain it with the Venn diagrams once again. So that is why I was suggesting that if you have a good understanding about Venn diagrams, these properties should be very easy to understand. Okay, if you have watched the last video, then we covered this question in the last video, right? This is exactly the same thing. So I'll draw two different diagrams for both of them to represent both the sides. So let's say this is the LHS and this is which is the left hand side and the right hand side of the equation. So let's say LHS equal A minus B and RHS equal A intersection B complement. So let's first try to figure out what is A minus B, right? We covered it in the Venn diagrams. A minus B is simply this region over here, right? That is A minus B, very easy to understand. And what is A intersection B complement? So if you try to remember it, B complement is just going to be this entire region around it, right? Around the B circle. And if I take the intersection with A, which is what is common between A and the B complement, I simply get this region once again. And if you take a look at it, both of these diagrams are exactly the same thing, right? And that is why we have this property over here. That is A minus B equals A complement, sorry, A intersection B complement. So I hope you have a good understanding about this property over here now. Moving on, let's try to understand the subset properties. These are very simple to understand, but let's try to read what it says. A is a subset of B. If A is a subset of B, then A union B is equal to B and A intersection B is equal to A. I'll try to explain it with example once again. So let's say I have A equals 1, 2 and B equals 1, 2 and 3, right? It says if A is a subset of B, subset meaning all the elements of A are in B. So think about it, right? All the elements of A are already in B. If I take the union of both the sets, which is combining all the elements together, it would simply result in the set B over here. So if I take 1, 2 union 1, 2, 3 would simply be 1, 2, 3 over here, right? And that is exactly what this says. And it says that A intersection B would simply be A. Why? Because think about it, right? All the elements of A are in B, but it's possible that all the elements of B are probably not in A. So if I take the intersection, it would be all the elements of A over here, right? So I hope you understand the subset properties over here. Moving on to the last property, I think this has been a long video by now. The cardinality properties. So I'll try to revise what is the cardinality once again. It's basically the number of elements, the number of distinct elements in a set, right? So for example, if A equals, let's say 1, 2, then the cardinality of A is going to be just 2 over here. I hope that makes sense, right? So try to read the statement over here. If A and B are disjoint, disjoint basically means that they don't have any common elements between each other. So I'll try to write down this definition. So think about it, right? If they don't have any elements common with each other, the cardinality of A plus B is simply going to be the cardinality of A plus cardinality of B. Let's say if I have A equals 1, 2 and I have B equals 3, 4. If I need to find the cardinality of A plus B, then think about it, right? A has 1 and 2 distinct elements, 2, plus B has other 2 distinct elements, 2 once again, which is going to be 4. But this is only in the fact that they don't have any common elements. In the case that they do have any common elements, then this is the equation that we have, which is A plus B equals cardinality of A plus cardinality of B minus the cardinality of the common elements between both of them. So if we take a look at it, let's say now in the case I have B equals 2, 3 and 4. the cardinality of A plus B is simply going to be A. A has 2 elements, 2, plus B has 3 elements, minus, I need to subtract the common elements between both of them. And I see that 2 is a common element, so I need to subtract 1 over here. So their combined cardinality is going to be 4 again, right? So I think we have covered all the properties by now. Now I'll be giving a few questions about all these properties. So I hope you guys can solve it, and then I'll try to solve these questions myself. Hey guys, I hope you were able to solve these questions. If not, it's totally fine. I'm going to tell you how we solve these type of questions, right? These are proof questions. The very important thing when you solve proof questions is that you have a very good understanding and a good, you remember all the laws basically, right? So that's very important. So let's start with this, the first question, right? Most of the questions that we have, if you are ever stuck in a problem like a proof, try to use the Venn diagrams, right? Try to visualize it on a Venn diagram, and I think it will make it a lot more easier to understand. So let's start with question number 1. I need to prove A intersection B complement is equal to A complement union B complement. If you remember, this is basically the De Morgan's law. So just like I said, I'm going to solve it using this Venn diagram question, right? So I have this Venn diagram. Wait. This and this over here. So I have A, B, universal set, A, universal set, right? Let's first try to figure out this solution over here. A intersection B basically means this common region, right? And complement of it meaning everything that's outside of this region, right? So basically, it's just going to be the entire region except this middle region that we have. I hope that makes sense. So this is basically the entire region, right? For this part, I'm given A complement, which is going to be, if you think about it, it's going to be the entire region surrounding A, and B complement is going to be the entire region surrounding B. And the only area that will be left in this case would be this middle part again. So this again would be this entire part. I hope that makes sense. Right? So it's very easy to visualize the De Morgan's law using the Venn diagrams. I hope that makes sense. Right? Moving on, let's try to solve this equation. Now, this is a tricky question, and usually you will have to solve these type of questions in your exams, right? But it's very important to remember all the laws, and if you do, then these questions should be pretty easy to solve. So let's start with this over here, right? Now, if you remember the laws, we already know about the difference law, right? Which is basically, so we have, yeah, the set difference law. I forget the laws too, to be honest, but so it's just like I said, it's very important to remember these laws, right? So the difference law states A minus B is basically equal to A intersection B complement. This is just in general. So if I have two sets A, and if I subtract another set, then it should be equal to A complement, sorry, A intersection B complement, right? So what I can do is, I'll start with this part. This will basically mean A intersection B whole complement. I hope that makes sense, right? I just applied the set difference law over here, so I'll write it down. Now if you see this equation, what I can do is, in order to apply the distributive law, I have to solve the complement first, right? That's very important. So how do I solve it? If you look at it, this is basically the De Morgan's law over here, which is going to be A intersection A complement union B complement. Now, if you notice, we have reached the distributive law position over here. So this is De Morgan's, and now I can solve it using the distributive law. So I get this union A intersection B complement. Now, if you remember from the laws, we know that A intersection A complement is basically just the empty set, and that is a part of the complement laws that we covered. So this is equal to the empty set union A intersection B. So this is complement over here. And now we are just left with, so think about it, right? Empty set union with this, right? So it would just return this entire equation over here, which is going to be A intersection with B complement. I hope that makes sense, right? This law over here would just be the identity law, because if you try to think about it, A intersection B, this entire set is maintaining its identity over here. So identity. So just like I said, if you have a good understanding of all the laws, then these type of questions should be very easy to solve. Moving on, let's try to solve question number 3. Now, when you look at this equation, it might seem very tricky in the beginning, right? But if I take a good look at it, this portion, which is this portion, it seems like the distributive law version, right? What I can do is I can take it the opposite way. So A union B intersection A union B complement would basically be A union B intersection B complement. Intersection with A. I hope that makes sense, right? B intersection B complement is basically the complement law once again. So this will be distributive, and this will be, so I get A union B intersection B complement results in the empty set intersection A complement. So this is complement. Finally, I get A intersection with A, which results in A again, and this is idempotent. So I hope you were able to solve this question. Just like I said, have a good understanding about all the laws that we covered. Moving on, let's try to solve question number 4 now. Given A union bracket A intersection bracket A union B is equal to A, and we need to prove it, right? Now, this we are already given in the question that prove it using absorption and identity. So I think this should make things very clear, right? Absorption, where would I apply it? I would apply it in this part. A intersection A union B. So this should directly result in A, which gives me A union A, right, is equal to A union A from, so A union intersection is equal to A union A from absorption, and this finally results in A from So I hope you were able to solve this question. I think this is the most easy one across all these questions, right? Okay, now let's move on to question number 5. Okay, if you have been given the cardinality of A is 10, so basically A contains 10 different elements, B has 7 elements, and we are also given the cardinality of their intersection. So the basic understanding that you can get from this question is that there are two sets A and B, and they have 4 elements in common between both of them. Now we need to solve for first I need to solve what is the cardinality of A minus B, and then I need to solve for what is the cardinality of A union B. So let's try to understand it. Whenever you have these type of questions, it's very easy if you use the Venn diagrams or you try to visualize these questions in your mind, right? So I need to figure out what is the cardinality of A minus B. If you remember the set difference, right? A minus B or A difference B basically means that I take the set A, I pluck out all the values which are common in both the sets. Now from the question, we have already been given that A has 10 elements and A and B have 4 elements in common, right? That is because we are given the cardinality of their intersection. So think about it, right? A has 10 elements, A and B have 4 elements in common. In difference, we pluck out those common elements. So this should basically be 10 minus 4, which is equal to 6. So I hope that makes sense. Moving on, we need to figure out the cardinality of A union B. Now, if you try to do 10 plus 7, that would result in 17. But you need to understand the fact that they have elements in common. And in the cardinality of set, right, according to the definition, the cardinality is the number of distinct elements in a set. But if A and B have common elements, if we add these two numbers together, 17 would be the incorrect number, right? Because that would mean that I'm adding a few elements twice. I hope that makes sense, right? So what I need to do is I need to add all the elements and then I need to subtract the common elements from them, which is I need to add A cardinality plus B, and I need to subtract what is common in both of them, which is A intersection B. So this is 17 minus 4, which is going to be 13. So this is going to be the answer. So I hope you were able to understand all these questions. If you were able to solve these questions, that's pretty awesome. And in the next lecture, we will move on to power sets and also move on to tuples.